Hey everyone, and welcome back, class 8. So we are going to be converting forms and comparing quadratics. Now I am going to encourage you to look back on video number 7 because there is a lot of overlap between the two, and I didn't want to go do the same thing twice because you have the video, so I would recommend looking back at video 7 again before attempting the content from this current lesson. All right, objectives for today: interpreting key points of graphs from quadratic functions. So looking at the functions, what can we tell from them? We're going to compare key points, particularly when the quadratics are presented in different forms. And we're going to do some factoring with the box method, just recap on that one, and use that to find x-intercepts. So essential questions for today: how do I compare quadratics when they're presented in different formats? And then what are the key points in a quadratic and how do I find them? So in the last video, and this is the one I want you to look back on again, we converted between the different forms. So we actually did the conversions between standard, vertex, intercept, factored forms, and all those. We wrote the equation of quadratics and then solved it. And solving was also an additional video, so make sure you check on that one too if you have any questions about solving quadratics. So the quadratic forms, just to recap, we've got vertex, or otherwise known as general form. We have standard form, and then we also have factored form, which can also be referred to as intercept form. And the things that we can tell from those, if we're looking at vertex form, we can tell the vertex based on our h and k values. We can also tell if there is a reflection or a vertical stretch or compression based on that a value. So just some useful things that we can tell just from looking at the equation. When you look at a quadratic is symmetrical through the vertex. So if you know the h value of the vertex, then you could say the line x equals h, I'm sorry, not y equals h, x equals h is going to be the line of symmetry for that particular parabola. So you can tell the line of symmetry from looking at vertex form as well. If you skip down to standard form, nice thing you can tell here is the y-intercept. So you can see where it's going to cross the y-axis, because if you put x equals 0 or f of 0 in here, this would cancel, you'd be left with c. So you can tell the y-intercept just from looking at the standard form of a quadratic. If you are doing any sort of projectile motion, so you would have minus an a value, and that's typically going to be the acceleration due to gravity. B of x is often our initial velocity, so velocity at time 0, and c is our starting height. So just some things to keep in mind as we move forward. Factored form, this is the one where you can tell the x-intercepts straight away. So we've got three things. If it's an intercept, the y value would be 0. So we'd have three things that multiply by 0. We know a is not equal to 0, so that means b or c must be 0. So we would put both factors equal to 0, so like x plus d equals 0 and x plus g equals 0. And then our factors, so the actual intercepts, are at the opposite of whatever is going on inside the factor. So if it's a positive number and a positive number, the actual solutions will be negative. If it's x minus d, then the solution will be positive d, so thinking opposites. All right, so I got a bunch of different functions here for you. F, G, and h of x, all in different forms. And you're going to have to answer questions based on those. So pause the video and try and answer the first 4 questions. Minimum x and y intercepts, minimum of h of x, and then which function has the greatest rate of change from 1 to 3. Pause the video, off you go. All right, welcome back. So the minimum of f of x. So we want to think about our direction. A value is positive, so this is going to open upwards. And we're going to have a vertex at 2, positive 6. So if it's opening upwards, that means the vertex is the minimum. So the minimum of f of x is going to be at when x equals 2, and the y value is going to be 6, or you could say minimum is at a coordinate of 2, 6, depending on what you're asked for. What are the x and y intercepts of g of x? So to get intercepts, you need it in factored form. So recap into that video about solving quadratics if you need a recap on how to factor, but we're going to have x, And then factors of negative 14 that add up to be 5, that is a positive 7 and a minus 2. If we want intercepts, we want to know when it's equal to 0. So that would be when x is equal to positive 2 or x is equal to minus 7. What is the minimum of h of x? So looking at this, you can graph it, you can put in Desmos, you can just kind of see what's going on. The lowest value on here for y is minus 2, 0. And then it is symmetrical on either side. So we can say, all right, based on that, this must be my vertex, my minimum. So we've got minus 1, 1, minus 3, 1, 0, 4, minus 4, 4, and then we got 1, 9, and 2, 16. So you can see kind of the shape our quadratic is taking. And it would be symmetrical on the other side if we kept going. So our minimum would be at 0 or at negative 2, 0. Which function has the greatest rate of change from 1 to 3? So that involves knowing the x and the y coordinate for both of those. Let's change color quick. 1, 9 is a point we know. Now looking at the pattern that's going on here, we've got 1, 4, 9, 16. Do you recognize these numbers? Those are the square numbers. So we've got 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So the next one would be 25. And so 3 would go with that. So 325. And then 1, 9. So let's start here. We've got x2 minus x1, 25 minus 9, all over 3 minus 1. 25 minus 9 is 16 over 2. So we have an average rate of change of 8 for h of x. So let's put these down here and then we can order them. h of x equals 8. For f of x, go change color again. F of 1. So if I put 1 in, I would get 3 times 1 minus 2 squared plus 6. 1 minus 2 is negative 1. Negative 1 squared is 1. 3 times 1 is 3. Plus 6 is 9. So we get 1, 9. And then f of 3. 3 times 3 minus 2 squared plus 6. So we got 3 minus 2 is 1, 1 squared is 1, 3, and we get 9 again. So 3, 9, also a point. So 9 was the y coordinate in both cases. So y2 minus y1, 9 minus 9 over 3 minus 1 is 0 over 2. So that's a slope of 0. So f of x has an average rate of change of 0 from 1 to 3. And then last one is g of x. So g of x, if we do g of 1, it's going to be 1 squared plus 5 times 1 minus 14. So 1 plus 5 is 6. 6 minus 14 is minus 8. So minus 8 goes with g of 1. And then g of 3, it's going to be 3 squared plus 5 times 3 is 15 minus 14. So we're going to have 9 plus 15 minus 14 is 10. So 3, 10 is a coordinate. So we got to go from 3, 10 to 1, negative 8. So 10 minus negative 8 all over 3 minus 1. So that'll be 18 over 2, which is 9. So g of x has a rate of 9. So from least to greatest, f of x would go first. So we'd have f of x, then h of x, then g of x. If we're talking about greatest rate of change between x equals 1 and x equals 3 in order. So that's very easily a question you could get on something like a unit test or a checkpoint because there's all the math involved, and then the final answer would just be to put the functions in order. All right, we're going to go again. Here's our functions once more. 5, 6, 7, 8, 4 more questions. Pause the video, take a shot at it. You're trying to find minimum, intercepts, value of h of 6, and then arrange the function for f of 2 from least to greatest. So rather than doing rate of change, we're going to say, okay, what is, if the x value is 2, which one has the greatest output all the way down to the least, and so on. Pause the video, and then come back. All right, welcome back. So minimum of g of x. So we figured out in the last slide what the factors were. So let's put those back up again. So we got x, 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 x. So we got x and x. Factors negative 14, that have to be 5 or 7 and minus 2. So we knew our zeros were at 2 and minus 7. So we know that the quadratic is symmetrical between common values. So like we're saying it passes through 0 at 2 and minus 7. The vertex is going to be halfway between those two. So halfway between 2 and negative 7. So it's 9 units between them. And that would be 4.5 is halfway. So minus 7 plus 4.5 would be minus 2.5. So at minus 2.5, we get our x coordinate. And we just need to figure out our y coordinate now. So g of minus 2.5 is going to be minus 2.5 squared plus 5 times minus 2.5 minus 14. Minus 2.5 squared is 6.25, and it's positive because you're squaring a negative number. 6.25, 2.5 times 5, so we get minus 12.5, and then minus 14. So we got 12.5, 6.25, and then minus 14 is negative 20.25. So our minimum is at negative 2.5, negative 20.25. Now you can also solve that by graphing. You can put it in your graphing calculator and look for the minimum. Put it in Desmos and it will give you the point, but you should be able to do it algebraically as well. And just recognizing that, oh, if I have two x values on a parabola that are at the same y value, so they have a horizontal line that can go between them, then the vertex is going to be located halfway between those two because it's symmetrical. So you find that line of symmetry, that x value, and then you plug it into your function to get the corresponding y value. X and y intercepts of f of x. So we would want to know when f of x is equal to 0. So this is one of our solving. So solving by taking square roots. So we would subtract 6 from both sides. So 3x minus 2 squared. Divide by 3. So we're going to get minus 2 equals x minus 2 squared. Now what happens there? We've got a negative number with a square. So something squared equals a negative number. It's not possible in the real world. So these are imaginary solutions. So we would say imaginary. We're not quite there yet for solving for imaginary solutions. Very soon we will start putting numbers in here, but for now we say imaginary solutions, and there's two of them. What would the value of h of 6 be if the quadratic continued? So we knew 3 went with 25. 4 would be the next square number, which is 36. 5 comes after 36, would be 7 squared, 49. So h of 6 will be the next one. So after 49, so that's 7 squared, 8 squared, 64. All right, arrange the following from least to greatest. Easiest one, h of 2, because we can see right there it's 16. G of 2, so if we plug 2 in, it's actually one of our solutions. So if x is 2, our answer is 0. And then f of 2, our vertex is at 2. So when x is positive 2, we get a 0, and that means our coordinate is the other point. So there's actually not a lot of math in this one. From least to greatest, that would be g of 2, f of 2, and h of 2. So answer being 0, 6, 16. So from least to greatest. How'd you do? All right, we're going to look at factoring now when the a value is not 1. So typically it's going to be either a fraction, or it's going to be a number greater than 1, such as 2, 3, 4, 5. And just the standard factoring method doesn't quite work here. So we're going to do what's called the box method, or sometimes known as the window pane method. You can see the steps on the side there, but I'm going to go through them with you. So we're going to solve this quadratic by factoring. So the first step is get it equal to 0. It is, so we're good to go. You multiply the a and the c value together. So 3 times negative 10 is minus 30. You then want factors of minus 30 that when you add them together, you get negative 7. So factors: 1, negative 30, 2, negative 15, 3, negative 10, 4 does not, 5, negative 6, 6, negative 5, 10, negative 3, and 15, negative 2, and then 30, negative 1. So if I add those together, I get negative 29, negative 13, negative 7, negative 1, 1, 7, 13, and 29. I'm interested in the one that was negative 7, so my factors are going to be 3 and negative 10. You make a window pane, or a box, divide into 4 equal pieces. Your a value, so from the original equation, goes in the top left. Your c value goes in the bottom right. What we do then is we put our two factors that we figured out, so 3 and negative 10. So we put like 3 in here and minus 10, and then they both get x's after them. So if I added all the pieces in the box together, I would get back to 3x squared minus 7x minus 10. Essentially what we are doing is we are rewriting this as 3x squared minus 10x plus 3x and then minus 10, and we are going to try and factor by grouping. So basically you're breaking it up into pieces that will allow you to factor by grouping. On the front line here, so on each of the spaces on the outside, you have to fill in your factors. So what would multiply to make the pieces on the inside? What would multiply to make 3x squared? Well, it would be 3x and x. The 3x is going to go over here. Reason is I would also need to multiply 3x by something to equal 3x. So just kind of spotting that I would need my 3x on that side, which means 1x goes up here. 3x times what is 3x? It's 1. And then x times what is minus 10? It's minus 10. And then if I do minus 10 times 1, I get negative 10, so it all works out for me. So my factors are 3x minus 10, and then x, and it's a positive 1, so x plus 1. So there is my 1 in factor form. And then if that's equal to 0, I can say 3x minus 10 equals 0, 3x equals positive 10, x equals 10 over 3, or x plus 1 equals 0, which means x is equal to negative 1. All right, let's take a look at some more examples. So your turn. Write each of the following in factored form. I don't need you to solve in this case unless you want to go that extra step and solve it, but just rewrite each of them in their factored format. Pause the video, try it out, come back. All right, let's see what our solutions look like. So the first one, multiply the a and the c value, 2 and minus 10. So we want factors of negative 20 that add up to be positive 1. So if you know the factors off the top of your head, you don't have to list all of them. So I'm looking for 5 and negative 4. So 5 times negative 4 is negative 20. Add them together, you get 1. So window pane. I've got 2x squared. I'm going to just make this bigger because this is very small. All right, 2x squared in the top. minus 10 down below, and I'm going to put the minus 4 and 5. It doesn't matter which one gets minus 4 and which one gets 5. Your factors will adjust accordingly. All right, so 2x squared, factors of 2 are 2 and 1. Since I have a minus 4 over here on the right, I'm figuring that I'm going to need 2x on the row part and then 1x on the column, because 2 times something is 4, but 2 times it would be a decimal to get 5, so that wouldn't work very well for us. All right, 2 times what is minus 4x? That would be minus 2. And then 1 times what is 5x? That would be 5. So my factors are x minus 2 and 2x plus 5. So 2x plus 5 and x minus 2. And we've talked a lot about checking your work and making sure you have the right answer. If you distribute this, you should get back the original function. So 2x times x is 2x squared. 2x times minus 2 is minus 4x. 5 times x is 5x. 5 times minus 2 is negative 10. Minus 4x plus 5x is positive 1x. We're good. So check your work. We know that's something we want to focus on. Second one, 5 times 12 is 60. So factors of 60 that add up to be 19. So we've got 1 and 60, 2 and 30, 3 and 20, 4 and 15. There's my factors, 4 times 15. So we go for our window pane, and we got 5x squared. We've got 12, 4x, and 15x. So factors of 5x squared are 5x and x. And again, I put the 5x down here because I know 5 times something is 15. So it's just going to work out nicely for me. If you had them in the opposite position, you would just realize very quickly, oh, it doesn't work out nicely. Let me try something else. And you just switch them and it works out. 5 times what is 15x? It is 3. And x times what is 4x? It will be 4. So my factors are x plus 3 and 5x plus 4. Check my work. 5x times x, 5x squared. X times 4 is 4x. 3 times 5x, 15x. And 3 times 4, 12. And 15 plus 4 is 19x. I'm good. Last one, 6 times 14 is, so times negative 14 is negative 84. And we need factors that add up to be negative 17. So negative 84, factors that add up to be 17. That is going to be, let me see, 21 times 4. Yes. So we got negative 21 because we want 17 to be negative. Negative 21 times positive 4 gives you negative 84, which add them together, you get negative 17. All right, so we got 6x squared. We got minus 14. Factors are minus 21x and 4x. Factors of 6. So factors of 6, now this time it's not a prime number, so it's not just the number in itself. So we're going to have 1 and 6, or we've got 2 and 3. 21 and 4, like those are both divisible by 2 and 3. So I'm thinking it's the 2 and 3. You can try 1 and 6 and see if it works out, but it's not going to in our case. So 6 and 4 are both even. I'm going to throw the 2x up here and then 3x over here. So 3x times what is minus 21? Okay, that's minus 7. And 2x times what is 4x? That would be 2. And then 2 times minus 7, negative 14. Perfect. So we've got factors 2x minus 7 and 3x plus 2. Check our work. 2x times 3x, 6x squared. 2x times 2 is 4x minus 21x minus 14, and 21 plus 4 is minus 17. Done. So please make sure you are checking your work along the way. It took like an extra 30 seconds for us to do that. All right, that brings us to the end of the day. It was a nice short one. How do I compare the quadratics in different formats? You are evaluating, you're finding those key points. So vertex or max or mins are key points. The intercepts are going to be a key point. Rates of change at different points along the way are going to be key. The direction, does it open upwards or downwards? And then just from each of the different forms, like the way it's written, being able to interpret different features of the graph. So like where the line of symmetry is, where the vertex is, where the intercepts are, and so on. And what are the key points and how do you find them? So the ones that we really care about, like how do you find max and min? So make sure you can do that in your calculator. Make sure you can do that using some of the methods we talked about. So if you know where the intercepts are, finding the line of symmetry, plugging it in. If you're doing it on a calculator, see the video on solving by graphing. And finding the zeros or the intercepts, that's pretty much our 5 methods of solving quadratics. So you find those x-intercepts. Y-intercepts, if you plug x equals 0 into the equation, you'll get the y value almost every time. And then after today, you should be able to finish Unit 2, Module 1. I did not put up another module, so you're just completing this module, and then you'll have the module checkpoint at the end as well. So it's a 4-day week. Make sure you use those 4 days to get all of that practice work done. There's a lot of practice work this week. There's only this lesson, and then finish it off with the math tasks and the checkpoint. Talk to you soon.